Hi there everyone. This video today we're going to be talking about the surface area of a cylinder, okay, and the formulas for that and how we actually work that out. So really the surface area of a cylinder comes from, if you have a cylinder like this, it's a very rough demonstration, and the curved surface area is the one that kind of people really don't understand. So if you have a cylinder like this and you cut it down the edge, it becomes a rectangle like this, right? So the circumference of the circle, it's a bad piece of paper to demo with, but the circumference of the circle, like this, that you once had, becomes the width of the rectangle. And the height of the cylinder is just the height, okay? So that's really the first part of this bit here, is that if you start with a cylinder like this, if I chop it down the side there and then put it out like this, you end up with a rectangle. This is the length of the rectangle. It's just the circumference of the top, 2 pi r, and h is just the height of the cylinder here, okay? Hence, the surface area of the curved part of a cylinder is 2 pi r h. Okay, coming from that formula there. You can see over here they've used pi d, pi times the diameter. Well, because the radius is twice the diameter, 2 pi r and pi d are the same thing. Okay, now whether the question asks you if you have a closed or open cylinder depends on the rest of the formula. Okay, so we know that the area of the top here is just the area of a circle, and that is just pi r squared. So if we have a closed cylinder, you've got 2 pi rh for the curved bit, plus 2 lots of pi r squared, the top and the bottom. If you've got an open cylinder, it would be 2 pi rh plus 1 lot of pi r squared, because the cylinder's open at the top and you're just counting the bottom. So in this question here, cylinder's 12 centimeters high, has a radius of 7. What's the surface area if it has a base but no lid? So it's an open cylinder. Right, so the surface area, again, I can do all this in one step. The surface area is going to be 2 pi times the radius times the height. That is the curved part of the cylinder, plus the base will be pi r squared. Now I think in the book they do these separately, but just grab your calculator out and look it up, and when you do that, you should get about 682 centimeters squared. That's rounded to the nearest centimeter squared, right? So you might get 682.48. Don't include all those decimals. In this case here, to the nearest centimeter squared makes sense. Okay, second one here is a closed half cylinder. So this is getting a little bit trickier here. Remember, the question is, what is the total surface area of this thing here? So we've really got 4 faces, if you like, here to consider. We've got this top bit here. We've got the curved surface bit going along the bottom, that half a cylinder, and then we've got these 2 end bits here. The other one over there you can't see. So I've kind of drawn a net of this shape here, and I've labelled those areas 1, 2, 3, 4. So 1 and 3 are obviously the areas of the ends. 2 is that flat bit, and 4 is the flat bit, this is the top, and 2 is the curved part underneath, okay? That when I stretch it flat will look like that. So we just need to work out what all the measurements are on there and then add them all together to get the surface area. So first of all, area 1 and 3 are going to be the same. So I'm going to say surface area. Area 1 and 3 are going to be just half a circle. So when you add 1 and 3 together, that is just the area of one full circle. So we know the formula of that is pi r squared, and the radius in this case is 0.4. Okay, the diameter there is 0.8 meters. So 0.4 for the radius. So then let's do area 2 now. So that is the curved part. So we know that for a full cylinder, we've got 2 pi rh is the formula for a full cylinder going all the way around. But this is just half. So I'm just going to get rid of that 2. Okay? And then that will give me half of the curved surface area of the cylinder. Okay? So let me put in those bits now that we need. So I get rid of that 2, and I need the radius in this case is 0.4, and the height is 4.3 meters. Okay, and 4, that's that bit along the top there. You can pretty clearly see that is a rectangle, right? 4.3 times the 0.8. And then you just do all that on your calculator. You could do it in stages, like do pi times 0.4 squared equals, write down the answer. Same bit here, write down the answer. Same bit there, write down the answer. And I think in this case here, that'd probably be worthwhile doing because you can see you've done each of those 3 bits. Then add them up together on your calculator. Just be careful when you do that you don't use the rounded numbers there because you can sometimes get a little bit out. So use the exact figures, pi times 4 is 0.4 squared plus, etc., etc., when you're doing your final answer. And I get 9.35 meters squared to 2 decimal places for the final answer there. All right, let's look at this example here now. This is I don't know what kind of shape this is. It's kind of a box with a half a cylinder on the top there, which is why I'm doing it in this video here. So we want to work out the total surface area of this shape here. You know, this could be a packaging that we use that someone would find that they'd buy, and you need to know how much material you need to actually make that. I've seen these kind of packages sold in the shops for making, they have little drawers and these things here and put all pens and textures and things like that in there. So we want to know the surface area so we can program this in and know how much stuff to buy. Right, so let's do the easy bit first, which is going to be the box at the bottom. It's got 1, 2, the back one there, 3, 4, and the bottom 5 sides there. Okay, so surface area, those 5 sides, we've got this front side here is 24 times 12, and the back one there is also 24 times 12, 4 centimeters. So that's the front and the back. The 2 sides are both 19 by 12. So 2 times 19 by 12. That'll be the left and the right hand side. And then we've just got the bottom, which is 24 times 19. All right, so that's the front and back, 2 sides and the bottom. Okay, so that bit there is done. Let me just erase that. Now, the trickier bit is doing the curved part, the curved surface area part. All right, so again, we've got 2 end parts here, which when we add them up together are just going to form one circle. So it's just going to be pi times the radius squared. Now the radius, that is from there to there, is going to be 12 centimeters. So pi r squared there will give us the area of the front and back semicircles. Now we've just got the curved bit, and as we learnt in the last video, it's half of the curved surface area of a cylinder. So normally the formula for the whole bit is 2 pi r h. So in this case here we've only got half of it, so pi times r, the radius there will be 12, and the height of that cylinder there is 19. That's it. That big long thing is your answer to the question. So again, you could work this out by working this out, this out, this out, and do these individually on your calculator, and then add all those numbers up there. But just be careful not to use the rounded numbers, because you might get it a little bit inaccurate at the end. So when you do that, you should get 2656.7 centimeters squared. Okay.